Welcome to another episode of Risk Engineers Talk Governance. In this episode, due diligence engineers Richard Robinson and Gaye Francis talk about safety integration levels allocation. This was actually a suggestion from Ben on YouTube, so we thank him for the idea. If you enjoy the episode, please give us a rating and help us spread the word. And also subscribe on your favourite podcast platform. Enjoy, and just like Ben, if you've got any feedback, please drop us a line.
Hi Richard, welcome to another podcast session.
Hello, pre-holiday Gaye. How are you?
I know, it's coming around fast. Today we're going to talk about, we've actually had a request for a podcast, which is quite unusual and very exciting. So we're going to talk about safety integrity level allocation, so SIL allocation, and the implications of that, especially under the WHS legislation. So, as always, Richard, hit us hard first and then I'll chip in when we go.
Excellent, Gaye. Well, there's a whole chapter in our larger book about this because this is something that's been a frustration for us for a long time. I don't know if anyone's aware, but R2A was the functional safety assessor under IEC 61508 when it was a draft in the late 1990s, I guess. And in fact, I think that was your first job when you signed up, because we were literally doing the functional safety assessment for how two trains would get past each other on single line track in New South Wales. And that was your job, to test that our allocation and the way in which the watchdog in particular was going to work would deal with every crossing, turnout and every other aspect of the system. So that started life as TOCS, Train Order Control System, and turned into TMAX, Train Management and Control System. And I think our certification stopped about 2015.
Yeah, it was about 15 years, I think.
It was only meant to be 10, as I recall, and they kept asking us to extend it because obviously we were slightly anxious about this, because if there ever had been a railway collision in that time, I doubt that we'd still be in business.
Yes.
Anyway, so at the time, my signature was on the train control room at Orange, which I gather has now moved somewhere else, together with my then business partner, Kevin Anderson. Now, this means we sort of spent a lot of times on this 61508, and it didn't become formalised, I think, until about 2001, 2002, and they're now up to the second edition, which is 2010, although because when Australia adopts it about a year later, it turns into IEC 61508 or AS 61508 2011, which is incredibly frustrating. Anyway, I think it's from memory, it's in 7 parts. Part 0, I think, has been a more recent thing. The first 4 parts relate to a general functional safety assessment standard, which is used for the 61511, the functional safety assessment standard for control systems, 62065, I think it is, for safety systems. And I can't remember what the nuclear one is, but since that's going to be our next podcast, you might recall that.
I'll make a note.
Excellent. Now, the bit that's caused us the greatest grief, in which the chapter is all about, is basically the SIL allocation, because it uses target levels of risk and safety as the basis for the SIL allocation. So what it asks you to do, and this is in part 5, what it asks you to do is do a hazard and risk analysis, work out what the current risk levels are, and then you have to work out what your tolerable or target risk levels are, and then you look at what the different control aspects are, like the existing external IRFs, I think they call them. They changed their name between the editions, which external risk reduction facility. And then whatever's left, that becomes your SIL allocation. So if you need another 2 orders of magnitude risk reduction, well then arguably that would be a SIL 2, depending on whether it's continuous or low demand and all that sort of thing. Now, so far as we're concerned, and that's where the crunch comes, using target levels of risk and safety, which was the previous ALAP discussion was all about, is absolutely verboten under the provisions of the WHS legislation. And that's why we've always felt that 61508 was a particular problem. Now, I think it's worth just commenting. I remember looking up websites in internationally a while back, just confirming about 61508. And I remember reading a website which I thought was particularly helpful, where it made the point that it's not a standard that's recognised good practice, it's the worthwhile ideas in the standard. So saying that the SIL allocation is an error in 61508, which is one section of one part of 7 parts, doesn't mean that the whole thing's futile or anything like that. I mean, if you have to go through the process of actually realising the SIL level that you've actually selected, then so far as we know, the standard works particularly well. But the problem is the initial SIL allocation, which, as we've demonstrated in all the studies we've done, is usually where the greatest cost occurs, in the sense that it commits you to a huge cost. I mean, basically, as far as we're aware, going from SIL 1 to SIL 2 to SIL 3 to SIL 4 pretty much means an order of magnitude increase for every SIL number that you go up by.
In cost, that
In cost, that is.
But we've also seen it being used in a number of other ways, and I think this is where people get confused about it, isn't it? We've often seen it used to allocate a reliability target for a system. And we've also seen it being used in isolation and allocating SIL levels to the electronic components without taking into account all of the other controls that are in the system to begin with. So they're often elevated SIL ratings than may necessarily be required.
Well, the WHS legislation is particularly clear. You've got to eliminate if you can, and that's an absolute categorical imperative. And then if you can't eliminate, then you reduce. And it's weird because you find this remark, and I sort of dug it out again. It's in the in about halfway into the first part 1, and it says something to the effect that, well, no, not within the scope of this standard. It is of primary importance that the determined hazards of the equipment under control are eliminated at source, for example, by the application of inherent safety principles and the application of good engineering practice. But that's just a note, like a footnote. It's not saying, you start with saying, can we eliminate this thing? And you might recall the Gateway Bridge example in Queensland. We got called in to do a SIL study on an anemometer and an electronic variable measure system for the top of the Gateway Bridge, which is up in the air, so you can get high winds up there. And high-sided vehicles, vans and so forth, can get knocked around by wind at that elevation if you're not expecting it. And so they wanted to provide people with
information of what
about wind speeds. The problem was, of course, if that information is an error, high, too low, or not there at all, and people are relying on it, that could then cause
an incident or an accident, and they were wondering what SIL level that this needed to be.
That's right. And this is where the IT people sort of encourage this process, as I recall.
They do.
Now, this perhaps you should take over here.
So we sort of spent the morning workshopping this and arguing for about a morning, and then we didn't really come to any landing on it at lunchtime. And then somebody asked, well, you've got the Westgate Bridge in Melbourne. What do you use in Melbourne? I said, there's flags on the top of it. So we don't have an electronic system saying what the wind speeds are in Melbourne, but you can tell by the direction of the flags, you know, which way the wind's going, whether it's a strong wind, whether it's not a strong wind, a visual indication. So we came back after lunch and we sort of landed on the control of putting a windsock on the Gateway Bridge, that if it was missing, it didn't give incorrect information. If it couldn't give incorrect information, and if it was missing, then the driver was, didn't have to make the wrong information wasn't given to the drivers. So I think that's what they ended up landing on, wasn't it? And the electronic system was ditched altogether.
Yeah, that's right. And so basically just put up a standard windsock you set an airfield with a light on it so you can see it at night. And if it's obviously blowing in one direction and it's rock hard and sitting out to one side, it's blowing a gale in that direction. And that's what was done. And all the SIL studies we've done, with rare exception, we've downgraded the SIL rating by at least an order of magnitude, very often by 2.
Yes, or no SIL rating at all.
Or no SIL rating at all, because it just didn't make sense. And the only way to do that, and particularly do it within the context of the WHS legislation. Now, you might remember that other study we did in Queensland, where the tunnel... to jet fans in order to sort of manage a fire in the tunnels. And it had been given a SIL rating, and the contractor, because it had to work through the OMCS, I can't remember what OMCS stands for, but it's the operating management system for the tunnel. The OMCS ran the ventilation system, and the idea was, I think it was sized that you could, if you turn the jet fans on, you can actually manage a 50 megawatt fire from memory. The design fire, I think, was for a heavy commercial vehicle type fire. we turned up to do this review, and it was kind of strange actually because, first of all, they'd obviously called it up as a reliability standard, as I recall, but they'd completely ignored the fire suppression system, which is an utterly independent system. And so when you looked at both these systems together, combined, there was a SIL rating in effect on the fire system which could already be incorporated, and therefore, from our point of view, the OMSIS didn't actually need a SIL rating at all. But what was particularly entertaining, if you recall, this was just before the WHS Act commenced in Brisbane on the 1st of January 2012. Right, so we were working this in November, December 2021. And I remember 2011, yeah, that's right. And I remember distinctly saying, guys, if we sign off under the old tolerable risk basis of things, and we sign off, there's a clause in the legislation that says anything that's signed off beforehand doesn't have to be done under the new one as long as you sort of got it underway. But if you fail to sign off it before Christmas this year, and the legislation commences on the 1st of January, we'll all be back here again in the new year doing it again. And all the technical people laughed at us, remember?
Yes,
they said, oh, you're kidding. And that was before the lawyer turned up and told them all to come back.
Yes, we were back in the February 2012, weren't we?
Yeah, we were.
But again, that because they hadn't sort of had the context right of the two systems operating independently,
Yep.
They had over-allocated a SIL level to the OMS, as you said, but they didn't take into account the other system.
Well, a fire system is normally a low demand system. That means it acts less than once per year, and it normally has about a SIL 2 low demand rating. Now, the ventilation system, with regards to fire, would have the same frequency, low demand, and so if you add two SIL 2 systems together, you're sort of up to SIL 4, which obviously doesn't make any sense at all for something like that. So anyway, I can't actually recall what did we do there. I think we said it didn't need a SIL rating, and I think we worked out, we actually did the numbers to work out what the reliability was, and the reliability was considered so high that whilst it wasn't formally SIL rated, it was sort of seen to be adequately reliable, as I recall.
That was my recollection of it as well, that when we actually dug it deeper into it, it was more a reliability target for operations rather than a SIL rating per se. Just before I guess we move on from the SIL ratings, I know that you've said we really don't know how they got the numbers.
No, the 10 to the minus 1, 2,
Yes.
3, 4 low demand, then 5, 6, 7, 8 for high demand.
They just seem to roll over from each other, so we've never been able to ascertain, I guess, where those numbers were derived from or how they came about.
No, I've asked a number of conferences I've been to on SIL studies and things like that and given papers, and I've always asked people, and it's just one of those things. I mean, I don't think we have a philosophical problem with orders of magnitude. I think we've always found it to be quite useful.
Yes.
But I've never seen any sort of scientific basis, as it were, for that understanding.
Yes. Now, we have seen SIL levels work well in other cases, and
Yep.
we did do a bypass again in Queensland, and it was a very narrow bypass that if a wider truck was going along the bypass, it was one vehicle at a time. They needed traffic signals at either end to stop the traffic.
Yep.
And that was a blind spot, so they did end up SIL rating that, but it didn't have a super high SIL rating.
No, that's
But
correct.
it was a combination of safety integrity levels as well as a reliability target that these things worked when they were required. So we've seen SIL ratings work really well. We've seen other times where there's been a misunderstanding of what SIL is, and they've been more aimed at reliability targets. So I guess with SIL, it's one of those things that you have to have an understanding of what you're trying to achieve. Always look at it in the context of all the other controls that you've got in place when you're trying to solve the hazard that you're doing, not just looking at the electronic component of it.
Well, that was the other one, the tunnel under the freeway, remember, under the airport.
Tugun bypass, so the Gold Coast Airport.
They wanted to SIL rate the VMS system for that, you might recall. And it was the IT people working in isolation because they failed to reflect on the fact that the civil engineers had gone to a lot of trouble to design the tunnel so that as you came around the corner, you got a clear view from one side of the tunnel to the other. And from a very practical viewpoint, if there's a fireball erupts in the tunnel, do you believe what you see through the windscreen, or do you believe the variable message sign on the side of the road? And the answer is you look through the windscreen and respond to that. So if there's a fireball in the tunnel that you can see, don't go in the tunnel. You don't need a variable message sign to be a high reliability saying don't go there.
And I think that's what it is. A lot of the time the SIL reviews have been done out of context.
Correct. I think that's correct.
So that would be probably our takeaway from this SIL podcast is make sure you've got the context right.
Because that will normally reduce the SIL level and save you generally an order of magnitude of cost.
Reduce the SIL level or eliminate the requirement for a SIL level sometimes.
Yep.
Many times actually. So get the context right, put your hazard in place, identify what your critical hazard is, and then look at all the controls that can be put in place. And often they're the civil design sort of things and mechanical designs before you even go to the electronic systems.
And don't do the target level of risk approach described in 61508 section 5, because so far as we know, you will be setting yourself up for some kind of potential criminal charge under the WHS legislation, the way the world has currently gone.
All right, so I hope you found that interesting. And as we said again, if anyone's got any topics they'd like to shoot us, we're happy to talk about those as well. So thank you, Richard.
Thanks, Gaye.
See you next time.
Indeed.